One of the things that we can use arithmetic or geometric sequences for is it can help us to identify a function. And so here in chapter section 9.6, where we're analyzing functions with successive differences, this corresponds to some information that we have here. So let's see what we have here. To determine which of these three types of functions, if any, represents a set of data. Now, the type of functions that we're looking at here are linear, quadratic, and exponential. And we're going to use our knowledge of arithmetic and geometric sequences, recognizing common differences or common ratios, to help us identify a function. So it says, observe a pattern in the graph of a function, or observe one of these patterns in the data. And we're going to be focusing here on data. And it says, and if it's a linear function, the first differences of the y values are all equal. In other words, we're finding a common difference, and that's going to tell us that it is in fact a linear function. Now, if we don't see a common difference as we go through and analyze the data the first time, but if we come back and look at the second difference, if those are all equal, in other words, if we have a common difference in what we're going to call the second differences, then we have a quadratic function. And if in evaluating and looking for patterns in a set of data, we find that we've got a common ratio between the y values, then we have an exponential function. So let's go over here to the next slide, and let's look at a couple and see if we can identify what type of function we're talking about here from the data. So over here on the left, I've got x and y values. And I'm really going to focus on the y values. And I'm first going through here to see, do I have a common difference? Well, the difference between -3 and -7 is -4. And the difference between -7 and -9 is -2. And the difference between -9 and -9, well, that's 0. And the difference between -9 and -7, well, that's +2. And I certainly don't see a common difference in this first set of differences. And in looking at this data, I can also see I can't possibly have a common ratio, particularly when I'm looking at this -9, -9. And versus the other data. So I want to then look to see, can I find a common difference from the first set of differences? Let's see, the difference between -4 and -2, well, that's 2. And the difference between -2 and 0 is 2. And the difference between 0 and 2 is 2. And so I've got a common difference in my second differences. And so this is telling me that this is a quadratic function. All right, well, let's look at this second set of data here, this second table of x and y values. Let's see, the difference between -18 and -13 is 5. And the difference between -13 and 8 is 5. And the difference between -8 and -3 is 5. And the difference between -3 and 2 is 5. Now this time in my first set of differences, I find a common difference. And when I find a common difference in my first set of differences, then I know this is a linear function. So we have evaluated and found a quadratic function and a linear function, but remember I said we're also looking at exponential functions. That kind of is going to give the answer away on the next set of data, but let's analyze it anyway. So here we got another set of data, x and y values, And I'm going to just proceed on this, just looking for differences, common differences. Well, the difference between 3 and 6 is 3, and the difference between 6 and 12 is 6, and the difference between 12 and 24 is 12, and the difference between 24 and 48 is 24. And then when I look at my second set of differences, well, then obviously I got a second difference of 3 here, but I've got a second difference of 6 here. And if I went ahead and did this on out, I got a second difference of 12 there. So I don't have any common difference between my first set of differences or my second set of differences. And so that's probably telling me I want to see if I've got a common ratio. So I'm going to switch to a different color and let's look at this. Okay, now to figure a common ratio, I take the second value and divide it by the first value. Well, let's see, 6 divided by 3 is 2. And then once I do that, well, I'm going to just go ahead and play it out. 12 divided by 6 is 2. And 24 divided by 12 is 2. And 48 divided by 24 is 2. And so I've got a common ratio. Don't have any differences, first or second, but I do have a common ratio. And when I find that, then I know I'm looking at an exponential function. All right. It's just a little trick we can use applying arithmetic and geometric sequences to determine what type of function we may be analyzing.